Good afternoon, everybody. Today, we're going to talk about the problem 1 of the 2022 US Open, USACO US Open, Platinum level. So this is a question of the 262144 revisited. The problem is basically like this. Let's say you have a set of numbers, A1, A2, all the way to AN. You can combine two numbers together. So for example, if you have a pair of 5 and 7, you can combine them together and you get the number which is max of this plus 1. So in this case, you get 8. Okay. So there's many different ways you can combine together until you get one number, right? So then let's say that number, that value is V. Okay. So what is all the possible V's if you combine all those together? So the question is, what is all the possible final number V? The sum of that, right? So so maybe you have, for example, if you have another way, you have another way to get 8. So you get, the two different approach to get V, then you count it twice, right? So then the V is the minimum. The minimum of the ways you do all of this together, right? So there's many different subset, right? So here, for example, they give an example, right? So for example, if you look at the subset of 1, 2, the first one, right? The minimum you can get is 4, because you combine those two is 3, and you have to add 1, 4. Okay. This question is actually very similar to the question that we had in 2016, right? So that's why it's called a revisited. If you look at the problem in 2016, that was the problem. The problem was, if you can have two numbers that combine together, right? So for example, in this case, you have 1, 1, 1, 2. If you have two numbers combined together, 1 and 1, they're the same. You can combine this and make a number higher than that. Okay, that is 2, right? So then you become 2, 1, 2. You cannot combine. But if you can combine this and this together, right? 1 and 1 together, you become 2, right? So 1, 2, 2. 2 and 2, because they're the same, you can combine them. Get 3. The maximum is 3, right? In this case. So this is old problem, right? So if you remember how to solve this problem, okay? So this was solved by a dp, right? So if we define dp of v of I, that means is get to a number j. So that means if you have a region, all those numbers, if you start from I and you want to reach the final value is v, what is the maximum j you need to reach? Okay, I mean, you reach j minus 1. This is open bracket. Right? What's the minimum j you need to reach in order to make that? So if you have v, if you want to get from v to v plus 1, that means you have to have that set, right? Also get v, So what is this number? Let's say j prime, right? J prime is obviously of dp. This region you get v, right? You start from j, right? So your dp is going like this, okay? So you have v. So basically your dp of v plus 1 I is basically dp of v of j, right? Which is dp of v of dp of v of I, right? So that was the dp you got last time. Okay, so this problem is very similar to the last problem. The only difference is it's not two numbers the same together, is you take the maximum, right? So that is very easy. If we follow the same concept, that is very easy to do. So okay, this is how we're going to do it, right? So basically, since we're going always go from v to v plus 1, right? So so this new problem. Okay. So they want to figure out how many of those. So then if each time, we want to, let's say for value of v, they are you have this much, okay? This is number of this intervals that can get value of v, right? So obviously you want to take this times that. To calculate, but you realize to calculate up to a number of v, exactly v is a little bit difficult. But we can play a trick here. What if we say f of v, okay, let's call this is f1, okay, f0. If we call f of v is number of those intervals, which is the value is bigger or equal v, right? This is number of equal has to be exactly v. Then we can do a for loop from v from 1 to all the way n, right? And then we just need to calculate. Every time we just need to add, right? So for example, if v is 5, let's say v is 5, what that means is for v equal 5, I can take all the intervals for v bigger than 1. I add it once, bigger than equal 2, I add 1 again, bigger than equal 3, I add 1 again, right? Bigger equal to 4, I add 1 again, bigger equal 5, add 1 again, right? So, add 1 again. So that will be your sum, right? So instead of just doing add 5, I can add 1 once. So I can easily do a for loop. Okay. This makes the transition easier because it wants me to get the maximum. When I get the maximum of two numbers, A1, A2, when I get the maximum of two numbers, it's harder for me to figure out how much is exactly v plus 1. But it's much easier, this is harder, right? But it's much easier for me to decide whether it's bigger than v. I don't care if it's bigger than 1, bigger than 2, bigger than 3. Okay. So if I do that, then I can just borrow this concept above here, and I can easily code it. So I code it here as an example here. Okay. So this is how I code it. Okay. So I'll give you a second to read this. Okay. So what I did is for each number, I need to find which location it is at, right? So I just read that in and find that. So for v from 1 to n, right? 1 to going up, I first add all the intervals that is bigger. I count how many intervals I have, right? So for example, if I have A1, all the way to A of I, okay? So if I have my dp of I, right? So my dp of I is at value bigger equal to V, what is my minimum J, right? That leads to this interval, will give me value at least V, right? So I want to count V plus one, so obviously I can, any of those, right? Every time I add one of them, the value will be bigger than V, right? Because it's take a maximum, I add one, right? So the number of those I have is n minus dp of I, right? So I just sum those together. So that's my value. Then now I'm going to do transition, right? Transition is easy, right? I do the same as what I did here. What I did above here, right? From my dp of I, right? The only thing I need to take care of is if I add a new value, because I add from small to big, right? I add from small to big. If there's a new value, let's say there's a new value ak, whose value is v plus one now, okay? So now the minimum, the new j is going to be the maximum of j should just come here, right? So that's what this part is about. So if I run this and I put a bunch of debugs there, so it's easy for you to see it and what I mean. So let's make it simple. Let's say two intervals. One is one, another is one, right? So I start with how many intervals I have. From here, I have, if I look at the value of one, right, means I have number, a combination bigger than one. So I can take this, right? So let me write it here. Okay, so I can have, in my case, is if my V is, if my V is one, right? If my V, so I want to look at everything bigger than equal one. So I have this interval, this interval. If I start from here, I can have 1, 2, right? That's what this is, right? If I start from here, I only have one of them, right? So that's why I have 2, 1, 0. Okay, then what's my J now? Okay, so my J is 0 and 1, right? But then my initial J, right? Then because I look at 1, right? So I have to update it. So this become 1, and this, 0 plus 1, right? So it become 1, 2. So now I look at my interval, right? At here my interval become this and this, right? My second interval become from here to itself, right? So now then I look at v bigger equal to, right? V bigger equal to this interval, right? So the maximum value is 2, right? Because 1, 1 is 2. So I can have one of them. But this one, the maximum is 1, right? So that interval, I only have one of them. So that's why I have one interval, I have no interval here, right? Then after that, then everything becomes and at 2, right? I reach the maximum. So I have 3 of them here, 1 of them here, so I have 4 of them, right? So those 3, remember, those 3 interval is, this interval this interval, and then this interval, right? So I have 1, 2, 3, and this, right? I have 1, 2, 3. And for v equal 2, I have this one. And this one doesn't work because the value is 1, right? So I can run another example. So for example, if I run, let's say I'll do 1, 2, okay? So you get up to 3, right? So the first case is the same, right? The second case, you add additional interval because this is 2, right? You can have an interval just 2, and that make it bigger equal to 2. Then for interval equals 3, this combined interval is bigger than 3, so you have 6 of them. Okay, so so what's the complexity here? So unfortunately, right? So I do a for loop here, right? So it's unfortunately the complexity is O(n) squared. So now I have to somehow make it from O(n) squared to O of n. For the first step, I have to look through all the values from 1 to n, right? So I can't change that. So then this, so I have to somehow make this O log n, right? So what is this? This is calculate how many, for a given interval, right? How many, a given v, how many n you have. And this part is updated. So then how do I convert from O log n squared to O n log n, okay? So this is, look at it. This is a merger of the number of merger of interval, right? So for merger of the interval, the typical trick is if you can find the max interval, define what max means, then typically number of max interval is usually there's n log n of that. So means even if you go through these loops, right? You go through these loops, and the number of times you're going to merge those intervals together. For example, this interval, right? This interval is merged by this and this, right? Number of times you're going to merge is n log n. Okay, so what is the max? Max, so here I can define max is this. Max is for this interval, if you extend to the left or if you extend to the right, the value v has to increase. You know, that's the maximum you can get. If you, and keep the value v, right? Because we loop through v, right? We want to get the maximum range, but it's still at value v. If you extend it further, it will be more than v. Okay, you can't extend further anymore. So example like this is if you have something like, for example, 1 and 1, right? And let's say 1, 1, 1. Okay, so this and here will be the maximum interval when value is 2, right? Because if you extend it, we're going to do max plus 1, right? It can become 3. Okay, so now, if let's say assume this is true, let me prove it later. Then how do I count this? How do I make this as log n or log 1? That itself is actually relatively easy as well. It's initially, you know, because I do, that's why part of the reason I want to do this, right? Bigger equal. Initially, how many if v equal 1, okay, how many number of intervals that has v bigger equal 1? That's easy. You know, A1, A2, I don't care how many of them, they're all positive, right? So even if they're all 1, 1, 1, 1, 1, you know, this is already bigger equal to 1, this is, and from here, this is, right? So basically I have n, and then I have a -1, I have a -2, and so on and so forth, right? So the total is n plus 1 divided by 2. That's my starting point, okay? So then from v equal 1 to v equal 2, right? Basically from v to v plus 1, how many I have is, let's say this is my, let's call it my count, okay? Count at 1, right? So what's my count at 2? Count at 2 is my count of 1 minus the, remember I'm doing, my original max interval is like this, right? So how do I grow to v plus 1? You know, let's say the other interval, you know, I have another interval, max interval like this. Obviously, I need to merge them together, right? Or I have another interval, you know, that are not overlapping. Then I just take this and I grow by 1, right? So this case, how many intervals? You know, basically minus the old, remove the old number of intervals that covers here, plus new, right? So in this case, it's very easy, right? So let's say, you know, you have k of them, right? That is k plus 1 divided by 2, right? This, for, I mean, for this case, and in this case, you have to consider this, but it's also relatively easy. So you can calculate this. And again, number of intervals you have is n log n, right? So, and each calculation is, you can do it by O1. So you basically use O1 times O n log n, right? So now you get log n of that, okay? So now we need to prove maximum number of this is n log n, okay? So how do I do that? How do I prove that? This goes back to look at the Benjamin Cheese guide, and look at the divide and conquer. Okay, I think it's in advanced divide and conquer. Okay, so basically is, let me do this. Okay, let me define. So let me, you know, let's say I have a point of P. At this point, the value is A of P, right? All the way to A of N. If I can count, you know, let's say F of A of P is number of those max intervals that has to contain P, right? It has to contain P, okay? So then the total intervals is my F of everything before P, right? Because before P plus this F of at that P plus F those after P, right? of the P. Okay, because f of P is defined by all the intervals that contain P. Right? So if I can prove this is n log n, and all of those, the whole thing will be n log n. Right? How do I prove this? So let's say, let's say for those intervals, if f of a of p, sorry, if a of p is the max value within this interval, right? So obviously the result is a of p plus 1, for example. Then you have to keep this. Then you can extend from here, here, right? So you can have p of them. So basically, f of a of p less equal p, right? So if AP is max, if AP is not max, so let's assume this thing will give you value of, let's say, v. Okay, give you value of this, then you have to, so then we'll need to calculate. So you give you value of this, right? But remember, this is something you cannot, this is max, right? What does a max mean? Is you cannot reach v plus 1, okay? So let's say there's another thing inside there, okay, which is, a value of bigger than a of p, okay? So the maximum way you can do it is you can choose go left, right? You have to contain this number, right? Obviously, you can choose go left, you can choose go right, right? So then f of this, for this, let's say a of v, okay, that's value of v thingy. It has to be less than equal 2 of v minus this a of p, right? Because we know this, there is a of v here, a of p here, right? How many you can go beyond this? You can go, remember, we cannot move more than v of 1, right? So the maximum you can contain, let's say all other are 1s, right? Every time you include 1, your a of p go up by 1, right? But a of p cannot go up bigger than v. So maximum number of 1s you can have is v minus a of p, right? But you can choose, maybe you can choose to use this or not use this, right? So that's the probability, right? And remember, that obviously has to be bigger, less than equal n squared, right? I mean, O(n) squared, right? Because the maximum interval we just said n plus 1 divided by 2, right? So that means, right? That means v minus a of p has to be less than equal to log 2 of n squared, which put it in the front, right? Okay, so then what you're going to, this is if value is v, but you're going to do sum, right? You're going to sum of this v minus ap from 0, right, to v minus of ap of this thing, right, equals 2 log 2 of n, right, for this together, okay? This number, obviously, remember this number, the maximum of this, as you can get, is less than p, right? So this number maximum you get is n, right? So log n of those n together, that is less than n log n, right? Okay. So now we figured it out. Okay. So what do? We go back to this code. So what we do is we can keep, instead of counting every intervals, let's say we keep a list of intervals, right? We keep a list of intervals. Originally is all by itself, right? All by itself. Yeah. So there are total n log n of those. Okay. Then for each one of them, we know how to calculate. I mean, initially the total number of all possible intervals is n plus 1 divided by 2, right? Then we're going to merge them. You know, for example, with each one of them we will extend by 1. Or if there's things like that, we merge them together, right? Become this and that. And then we minus the old one plus the new one, which we know how to calculate, that I just described up here. Right. Okay. So because those merge is, we only have n log n of them, right? This merge is n log n. So the end result is going to be O n log n. Okay. The basically is we take what we did in 2016. We take what we did in 2016 and we extend the same concept to here. We first use this to do, same concept, right? We first do this. However, this is only n log n. That means it's good up to for case 1 and actually it's good for case 3, right? Because the value v is up to 40. Okay. So then we need to figure out how to optimize this from n squared to n log n by using this combination of this max. Okay. So today's homework actually will be a little bit interesting because there's another way to do this. The other way to do this is to basically, you can actually calculate, again, this merge and figure out how many intervals you have. Obviously, the other way to do it is use a segment tree and then use merge is kind of like lazy update, right? Using lazy update to merge two things together, then how many is in there, just like I said, right? How many is in there, we know how to calculate. Okay, so here is a code that will give you use a segment tree. And actually, you have to use 2 segment trees. One is to get the max, another is to get the lazy update. And it's implemented by bit, but yeah, we all know, right? Bit is just another way of looking at the segment tree. So just using segment tree to calculate, and with lazy update to calculate how many you have. Then each time, right? Then each time you just get number of intervals times that value there. So I give you as a homework to read this, and the speed is also pretty good. The networks, right? It's barely, barely reach 1 second, 995 milliseconds. Okay, so the homework is for you to go read this code and understand how it was implemented using a segment tree approach. Okay, so that's today's homework. This week's homework. So that's a question. That's for this problem today. And in next week, we will talk about the problem number 2. Just a reminder, this week we'll talk problem number 1. Next week is problem number 2. The week after is problem number 3. And then after that, we still have 6 more classes left for this season. We're going to talk about the last year's IOI problems and solutions. So 3 for day 1, 3 for day 2, right? So a total of 6 problems from 2021 IOI. Okay, good luck and have a good weekend.